This is MC dropout. This is MC dropout. Okay, so MC dropout provides you more information about the uncertainty. Because sometimes you want to know, okay, we know the highest probability is this class. We know that. But sometimes you want to know, okay, if it's not the first one, what is the second most likely class? Or the third one, if that matters. The original model doesn't tell you that. It doesn't tell you the second most likely class or third most likely class, with a lot of information. But if you use MC dropout, you are able to obtain that information, okay, and be able to estimate, okay, how trustworthy this class, each class is, okay, by this MC dropout. Okay, so models still think the image belongs to class 9, but only with a 62% confidence. Okay, so which seems much more reasonable, okay, than 99%. So plus it's useful to know exactly which other classes it thinks are likely. And you can take a look at the standard deviation of the probability estimate. Because now you have 100 estimates, right? And you can do standard, not only you can do average, you can do standard deviation as well. Okay, and obviously not only the average, but also standard deviation tell you that how trustworthy the result is. Okay, the result is. So this thing, the MC dropout, okay, is especially important when you are building a model for a risk-sensitive system. What is risk-sensitive system? Such as medical or financial system. Because in a medical or financial system, okay, a decision has a lot of consequences, right? I mean, if a decision is wrong, then in a medical system, maybe a lot of persons' lives will be spared or will be wasted, right? Okay. Or if in a financial system, okay, if a decision is wrong, you may lose millions of dollars, right? So it is very important to make sure how certain the decision is. Or it's very important, okay, to know, okay, so this is the first most certain answer. What is the second possible answers? Or the third one? Okay, sometimes you want to know much more information than just, oh, this is the answer. Okay, you want to know a lot than just the answer. You want to know the certainty of the answer. You want to know the second best or third best answers. Then the original model couldn't provide you that, but the MC dropout can do that for you. Okay. So the model also, okay, once you use MC dropout, and obviously you are still going to take the class with the highest probability as the answer, right? And then, okay, if you try to estimate, okay, remember we do this, every instance in the test set for 100 times, right? And then we do the average, and then we use this to see if the accuracy of this model, and interestingly, okay, the accuracy now is 86.94%. It is also slightly improved because original accuracy is 86.8%. Now it's 86.94. So this one is better than 86.8. Okay? So, well, we are not training the model, right? We are just using this model to do the inference many times, right? With the dropout turned on. And we are able to improve, not only, be able to estimate uncertainty, we are also able to improve the accuracy of the model. So this is a very interesting approach. But of course, like how many times of the inference do you want to apply in the MC dropout? In the example that I just show you, okay, we use 100, right? We for every instance we basically inference for 100 times, and obviously, okay, the more number of time you inference for each instance, well, the accuracy actually increase a little bit, okay, but at the same time, you are going to spend more time on the inference, right? So this is a trade-off. This is a trade-off, okay? Like the number of times you inference in each instances, and you know, the accuracy at the time is a trade-off. So it depends on your application. So it's trade-off between latency and the accuracy, okay? To decide like the best number of inferences you should do for each instance, okay? So if your model contains other layers that behave in a special way during training, okay, such as batch normalization layer, then you should not force training mode, okay? Because I mean, in the training mode, the model will behave differently, okay? So you should replace the dropout layer with this one, okay? With the MC dropout. This is a subclass of the dropout layer. Basically, it do exactly the same thing, okay? You just try to subclass the dropout. To create this MC dropout, and then you create this MC dropout, and then you do this to avoid like being able to invoke the batch normalization, like when you do the MC dropout, basically, okay? But here we just subclass dropout layer, okay, and override the call method, okay, to force its training argument to true, okay, so that like we can, we don't need to set the training to be true, like when you do the MC dropout, okay. So so of course, like if you use alpha dropout, you can subclass MC alpha dropout class as well, okay. I mean, basically you can do exactly similar thing for alpha dropout class, okay. You can subclass that one to create MC alpha dropout, okay. And if you are creating a model from scratch, it's just a matter of using MC dropout rather than dropout. But if you have a model that was already trained using dropout, then it's more complicated. You basically need to create a new model which is identical to the existing one, okay? Except it replaces the dropout layers with the MC dropout that we just created, and then copy all the weights to this new one, okay? In order to to use the MC dropout, okay? So basically, MC dropout is a fantastic technique which boosts the dropout, dropout models and provide better uncertainty estimates, okay? But since it's just a regular dropout during training, so it also acts like a regularizer. So MC dropout is also a regularizer, okay? So which is again a very good one, okay, to consider, okay? But of course, normally we consider MC dropout, most of the time. I mean, when we are building risk-sensitive systems, okay. If your system is not risk-sensitive, I mean, regular dropout already work pretty well, okay. So, well, oops. I think I spent too much time, right? Okay, I skipped the one break. So let's take the break, okay? For 10 minutes. I mean, we will start the next class from like 2:10. 2:20. Okay, sorry about that.